Shall I? We'll start with AWS. Please go to the page on GitHub, the concept page. I'm posting it to Slack. It's our regular GitHub page. This is what you'll see. We're going to talk about a couple of things that are left out in compute, and then we will move to storage. All right. After this basic AWS is done, we will be moving into Kubernetes. This is your Kubernetes concept space. You can see it on the same repository. And we'll be talking about the Kubernetes primitives. All right. We want to start a little bit hands-on today on Kubernetes after 2 days of theory. All right. Yesterday, have you guys started S3 or you haven't, isn't it? Yesterday was only EC2. Okay. Let's get back here. Black mark. All right, so we talked about IAM, then we talked about EC2. All right, in EC2, what did we talk about? Types, and then instance types, then AMI. That's fine. Pretty much it. Now in EC2, there is another concept. We talked about spot fleets, right? Yes. What is a spot fleet? It's a group of spot instances, all EC2 instances, together called a fleet of EC2 instances. It's like a group. All right. Now, similar to this one, there is another thing called auto scaling group. Let's see what it is. You will come across this thing very frequently. It's a practical uses one. Auto scaling group. By now, you already know it's pretty easy to launch a EC2 instance in a cloud. You don't have to really go through all the pain of buying a server, setting it up, network, all that not. It's already taken care of. You just click and EC2 instance is up, or you run a command, your EC2 instance is up. Now the cloud has taken it one step further, and what they've done is, just like spot fleet or anything, let's say you have an application which is running on one EC2 instance. Very simple. Take the example of same thing, Amazon. All right. Let's say Amazon website or similar website is running on one EC2 instance. All right. Now, when the load increases, consider on a sale day, big sale day. On a sale day, obviously, the load is going to be at least 10 times more than what normally would be. All right. Which means the single EC2 instance cannot actually handle all the load. Now, to manage such a load, what are the options we have? We can increase the number of EC2 instances. This is another EC2, this is another EC2. Spread our application across all the three. But only on a sale day, you will be using all the three. Once the sale day is over, let's say once a week you are running a sale day, Sunday, or once 2 days a week, weekend, Saturday, Sunday. Which means only on Saturday, Sunday, all these three are being used. The remaining 5 days, these two are pretty much useless. You are wasting a lot of compute power, which means you are wasting a lot of money. So what AWS or other clouds facilitate is, they give you something called auto scaling group, ASG. What it allows you is, it allows you to define the number of EC2 instances you want depending on the load. Let's say you can say, if the CPU of EC2 is 50%, launch another EC2 instance. Automatically scale it. It is similar to spot fleet, but what happens in a spot fleet is, it goes down, the spot fleet will automatically bring up another one. The focus here is to maintain the number of EC2 instances, not necessarily worry about the load on each one of them. If you mention that I want 6 spot instances, the fleet will ensure that there are 6 spot instances. If one of them goes down, a new one will be launched. So spot fleet is about the number of EC2 instances. It does not really worry about the usage of the spot fleet. Whereas ASG focuses on the usage. You can say, my CPU is 50%, launch it. You can give other parameters, like my RAM is 90%, launch it. Like that. So you can launch as many as EC2 instances you want. So to define this EC2 instance, you will give what is called a template, or what we call a launch template, which will be used. A launch template is basically the specifications of the EC2 instance you want. We know how EC2 instances are launched, right? You give a type, isn't it? Once you give the type, you know what AMI are. You give the AMI. Once these two are there, you have EC2 instance. Then you give 3 parameters. Minimum number of EC2 instances that should be running in this ASG. What would be the max? Some max value. Then there is a third one called desired. Yes, this is the average one you want. So the ASG group will try to maintain your desired. Definitely it will maintain the minimum. Maximum it can go up to this thing. So based on your requirement, you will decide the maximum number of EC2 instances you want. So taking care, talking about the scenario that we were talking. If you want, let's say on a big sale day, Saturday, Sunday, let's say if you want 4 EC2 instances, you are assuming 4 will be the actual size that I want. So you will give max 4. Min has to be 1 on a normal day, at least 1 should be running. Desired, you probably want to run only 1. At least 1 you want it always. Or you can have 2, whatever it is. So once you give these 3 things or 4 things as part of your launch template and attach it to a auto scaling group, you have basically an elastic EC2 group of servers. You don't have to really worry about load anymore. The load part is taken care of. Now this is the biggest advantage of running a cloud. You're not worried about the infrastructure anymore. If the load increases, fine. If the load does not increase, fine. Because of that, your business can be more flexible. Yes, you can decide, okay, we're going to run a sale day tomorrow. Earlier, if you have to run a sale day, you have to first contact the IT. IT has to approve it. Then only once IT approves it, they will set up everything and get it ready, which used to take a lot of time because it has to be tested again. Now with cloud and with this concept, similar concept, auto scaling group, you can define a launch template, you pretty much have it. So if nobody is using it, you just have one EC2 instance. If thousands of people are using it, you have lot of EC2 instances. Alright, that's another concept in EC2. So that would finish our EC2 things. Let's move to storage. Okay, there are 2 other things. Compute we talked about EC2. It's just like a virtual machine. There are two other things in compute. One is Lambda, other one is light sail. EC2 and light sail are pretty much same. The only difference is EC2 you get a per minute billing kind of thing. Light sail per month billing. It's like you renting it for a longer time. When you rent it at a longer time, you get it at a pretty cheap cost. Light sail. Alright. They are same. There's not much of a difference. There are little limitations to light sail. Light sail is recently launched. When they have a competition from other cloud providers like DigitalOcean. DigitalOcean gives you a 1 GB virtual machine for 1 month for $5. $5 is how much? 350 rupees. Alright. Now what is happening is all the small developers, everybody started using DigitalOcean. Now AWS is losing money, not because they are not using AWS, but if somebody is not used to AWS, they're never going to use it later also. It's like, you have to grab the customer first. Once you have the customer on your platform, eventually they use it. And especially developers, if they start using any platform, they're going to say same thing to the company. Okay, we are using AWS, let's use it. You are more likely to recommend something that you are already familiar with. So it's important for AWS that all the developers use their platform. And when developers use it, they don't use these kind of big fleets and everything. They just use one instance. So EC2, they were losing money, our developers. So they launched this light sail recently, probably 2 years before. All right. So the light sail is also EC2. Only thing is on a monthly cost, you will acquire it. Now usually we don't use light sail. EC2 gives a better one for production. All right. They both are same. Now let's look at Lambda. If you have to run a software like a simple website, all right, static website, let's say. What are the website contents usually will be on a static website? What kind of files you will have? Details space. So you have HTML files, CSS files, couple of images, let's say. That's all. Let's say no dynamic code, nothing. You have some 2 or 3 HTML pages. Those pages have certain images embedded in them. And all those pages are rendered using a CSS style sheets. Now, such a static website, what kind of server can run such a static website? Give me a server name. Do you want to run that website? How do you do that? Yeah, so HTTP. So you need a HTTP server to run that. What is a HTTP server? You are familiar with? HTTP servers. Apache. Anything else? Nginx. They're not out of sleep yet, isn't it? Get up. 7:30 it is, alright. Alright, so you have an Apache server running on some EC2 instance. And you put your HTML files, let's say 1.html, 2.html, 3.html. What's the location of Apache? Default location? Where? That's correct or reverse? Okay, I always have that confusion. So you have a HTTP server with all the files you want. Alright? Now this, your launch. Now if you have to manage this server, who has to take care of the EC2 instance or launch the EC2 instance? Let's say you are the admin. Alright? You are the cloud admin. A developer has given you 4 files. He said, launch the EC2 instance, set up a Apache server yourself, copy these 4 files here, give me a URL. It has to be done by you. You are the admin. Alright. Setting up EC2 instance you have to do. Setting Apache server also you have to do. All that the developer is going to give you is these three files. Probably they'll send it to you in your Gmail. Done a job. Right? Now you were given a task of make sure this is always up. Now what are the various things that you have to take care to make sure this is up? You have to make sure the EC2 instance is up always. You have to make sure the Apache server in the EC2 instance is always up. These are the two basic stuff. Alright? Which means you have to have some kind of monitoring mechanism that sends you an alert, an email or WhatsApp or SMS, whenever something goes wrong with these two. So the whole administration of this thing has to be handled by you. What AWS says is, this is really useless. And this is also useless. You just get your HTML files, we will take care of everything else. That's your Lambda. So on a regular application, you take care of all the EC2 instances. Lambda, everything is taken care by AWS itself. Now this is usually called serverless. Serverless compute in this case. Now when you say serverless, is it actually serverless? Means without server things are happening over there. Nothing can run without a server. We could not invent such a thing yet. You need servers to run softwares. Now the serverless here means you don't have to manage the server. That's what it means. Like if I say, vehicle-less travel, if I say, does that mean you don't need a vehicle to travel? You are going to fly across? No. It means somebody else is going to take care of your vehicle. You still need a vehicle to travel. So if somebody comes up with the word vehicle-less travel, the actually mean is you don't own the vehicle, you don't operate it, you don't have to manage it, you don't have the headache of doing anything with vehicle. We give you a vehicle, we take care of everything. You just sit in there, travel. That's vehicle-less travel. The same way, serverless compute. You still have server, you have to still have Apache server, but you are not doing any management. Instead, AWS does it, and they call it Lambda. So all that you have to do is bring your 3 HTML files. We will give you a page where you can upload these 3 HTML files. After the upload is done, what are they going to do? They'll launch EC2 instance, they automatically set up an Apache server on it, and they copy your 3 HTML files into this directory, and they'll throw an URL at you. All those things are done. Whatever you are doing, somebody is doing it. Either a script or a person, whatever it is. But the things haven't changed. So if you don't do all this stuff, if AWS takes care of it, this is called serverless compute. Means you do not have to worry about the servers. All that you have to do is bring your application. So such a thing is called Lambda. And these are really called Lambda functions. That's what they are calling it. Lambda functions is the serverless compute. Now this is usually very efficient if you have only developers in your company, no system admins. Because this work requires system administrators. And this is useless work. You are not really focusing on developing. You are focusing on managing stuff. Alright? Like let's say you have a bike. And every day you're just cleaning it up, making sure it's neat and making sure it's working. You never have time to travel or use the bike. Is that useful? Such a mechanism? No. You would rather go to Vogo, pick it up, and then go anywhere you want and throw it at them again. That's a better way, isn't it? So that you can focus on travel only. That's what you want. You want to travel, right? It's not like you want to have a bike and keep looking at it. Nobody wants that, isn't it? So the same way here, there are a lot of companies, especially startup companies or everything, they don't want to have resources or they don't want to worry about managing their EC2 instances. They want to focus on the application. Let's say you are a startup. You have nice developers with you. They are all coding. But if we have to do this model, we have to manage EC2 instance, means one of our resources is obviously occupied with that old stuff. If only there are 3 in a startup, if one of them is occupied, obviously you're wasting 33% of your resource. That's huge wastage. Instead, you can go to AWS, put your application in Lambda format. Now the Lambda format gives another advantage. It's infinite scalable. What it means is, let's say you have a nice website here. All of a sudden, you became really popular. All right. And one day, Bill Gates tweeted your website name. Then pretty much on that day, probably 1,000, 2,000, or 10 lakh people will try to hit it. If it is a single EC2 instance, it cannot handle. If it cannot handle, people will have a bad name. Okay, only Bill Gates is just unnecessarily tweeting all these things. It will spoil Bill Gates' brand name, your brand name also. Right? To make sure that there is no such thing is happening, if you choose Lambda, Lambda will automatically scale up. Scaling up is nothing but they just automatically launch EC2 instances whenever they need. If the load is increasing, it's a simple auto scaling group internal. It keeps on increasing. Now, the billing for Lambda is usually done by the number of requests that are going in and out, not like the whole storage. So from a billing perspective also, Lambda is more efficient compared to EC2. If that is the case, why people still use EC2? Why can't everybody go to Lambda? They're saying Lambda, everybody, they take care of everything and the cost is also less. And why not everybody use Lambda? Why people have this EC2 stuff?
It's not under our control.
Exactly. Control. That's correct. Control. You want control of everything that you are doing. Why you want control? So that you can move it out of AWS into Google whenever you want. Now, the moment you have control with negotiating with AWS. Okay? Either you give me at 50% or I'll go to Google. Our Microsoft executive is sitting in my conference room. Either you confirm it at 40% or at least half of this I'm pushing it to Azure. The moment you have control, you have bargain power. If you say you are on Lambda, okay, you do whatever you want to do. We're not going to reduce your money. That's called usually a vendor locking. Vendor lock-in is something like you use a very specific product of a vendor and you will not be able to move out of that vendor whenever you choose. This is considered to be a bad thing in software. You don't want to be tied up with any one person. Like MS Office, you are vendor locked in. You don't have a choice. You have to use MS Office. All right. So if your company is using MS Office, you have kind of vendor lock-in. The same way, if you are using Windows, you have a vendor lock-in. There is no other company that offers Windows. Linux, on the other hand, is not a vendor lock-in. If not one company, another company will offer services on Linux because Linux is open source. Nobody can sell the code. What people can sell is the services on Linux. Means if you have a problem with your operating system, we will fix it. That's all people can say. Nobody can say, we are selling you Linux. Linux is not owned by anybody. So the vendor lock-in is usually avoided. That's the reason probably you would not want to go ahead with Lambda. You want to have an EC2. Also, there are other kinds of issues like a specific version of your application you want here. That probably is not available here. Let's say the Apache server, you want 2.4.33 or 36, very specific. Your application runs only on this one. The Lambda may not offer this version of Apache. Then you don't have a choice. You have to go ahead with your regular EC2 model. All right, that's some of not everything is available in Lambda. Right. So those are the three things in compute. Any questions here? There are no questions. We'll move to next thing. Okay. Let's move on to the next thing in our AWS. Storage. So I'll write down here. We finished IAM. Then we talked about compute. We're moving into storage. Then we will get into network, other stuff. In compute, we have EC2, Lambda, Lightsail. Storage, you have three: S3, EBS, EFS. S3 is simple storage service. EBS is elastic block storage. EFS is elastic file system. File system or file storage. Anything you can say. Let's talk about these two first. This is the keyword. So block storage versus S3 is this thing. S, S, S. That's what S3 is. Alright? Simple storage service. That's why they call it S3. The same thing like EC2, Elastic Compute Cloud. Alright? Now here, elastic block storage is EBS. This is the hard disk that we always talk about. This is where the operating system usually gets installed. The same thing that you have in your laptops. That's exactly EBS. Now, as compared to EBS, S3 is slightly different. This is called object storage. Let's see what it means. So S3 is object storage, EBS is block storage. On EBS, you can install, it's like hard disk. On S3, it's like a G drive. G drive is a storage. Can you install operating system on it? You have 15 GB, right? Can you install Linux on it? Why not? It's not temporary, it's permanent. Always have your files. Yeah, you can remove it, but can you install an operating system and remove it? Why not? You understand the difference? There's something that is different about G drive. It does not allow you to install an operating system. It's only storage. And what you can do, you can put a file into it, you can get it out of it. These are the only two things you can do, probably. Not much beyond those 2 points. That is objects. You can put objects into it, you can get objects out of it. It's pure storage, like your G drive. You cannot install an operating system because operating system installation requires that it has to be, the hard disk has to be divided it into blocks. This is your hard disk, all right? It will be divided into blocks. Each block has a number associated with it, hexadecimal number. And the operating system tracks these blocks by the hexadecimal numbers. That's how it operates files. If you are reading a file, your file is probably across multiple blocks on your hard disk. There is a file descriptor and file pointer. So that descriptor or pointer will have all the links to all the blocks. That's how the operating system reads your file. Now this whole thing requires that your hard disk is formatted in a specific format. What you see NTFS in Windows or FAT32. If it is Linux, ext4. So the file system, what gives the operating system ability to read files, write files, edit files, do all that stuff. That is your block storage, because you are dividing the storage into blocks by blocks and you are able to access all those blocks using a technology. Whereas object storage does not allow you to divide it. Object storage only gives you space. All that you can do is you can put files into it, get files out of it. Like for example, you can put a PDF into it or an image file into it. You cannot open a PDF and edit it. You cannot open an image and edit it. Even if you are able to do it, that's not from the storage itself, that's an additional application. So from the storage, they transfer it to another application and then they will allow you to edit it. For example, on Google Drive, if you open a doc, it opens Google Doc. That is not the drive's capacity. From Drive, you are taking it to doc and opening it. It's just like downloading the whole file to your laptop and opening it in a regular Windows doc. No difference. So the storage itself does not provide you any edit capacity. It only allows you to store objects and retrieve objects. That's all it does. Now then, why do we use this thing? Why can't we just have block storage everywhere? It's costly. Managing this is costly. And this is not really scalable. For example, if you see here, the max you can do is about 2 or 3 terabytes. Beyond that, your file system starts to falter. It also slows down because it has to refer everything. It's just a pointer, means it has to read all the blocks, right? Which means there is an operation, CPU operation involved in it. Now it's slow beyond certain point. Whereas this one is not. You're not doing anything here, no blocks, nothing doing here. Alright? So you put a file completely at one place, you take it directly out of that place. So object storage is mainly used for storage. You want to store something. Like the photos in your laptop, let's say you want to move them to cloud, you put all of them into some kind of object storage. You can put it into G Drive, or you can put it into OneDrive from Microsoft, or if it is an enterprise level, you can put it into S3. Let's say your Instagram. Instagram is all about photos, isn't it? Where do they store the photos? They need some kind of object storage. Huge number of photos. Or your Pinterest. Or TikTok. Videos. Where do they store? What is the latest one? Takatak. Yeah, that's one. Where do they store? So they need some kind of object storage to store the objects. So S3 is the object storage. Whereas EBS is a block storage. So when you launch an EC2 instance, what do you need? You need S3 or EBS? You need EBS because you want to install the operating system. So your AMI is actually EBS. So this storage gets attached to your EC2 instance. So let's say you have an EC2 instance. There is one EBS volume attached. On that EBS volume, your AMI gets copied. This is your operating system. This is about 10 GB or 8 GB it will be. Now, if 10 GB is not sufficient, you want to have other additional hard disk, you can attach other EBS storage. These are called volumes. So you can have EBS volume 1, 2, 3, 4. Each volume you can decide how much size you want. So any EC2 instance can have any number of EBS volumes. Now if this EBS volume is here, can we attach this EBS volume to another EC2 instance? Let me give you an analogy. Can you add the same hard disk to two laptops? Why not? You can? It's pretty much same. External hard disk, let's say. You got an external hard disk, you got two cables. Can you attach it to two laptops? That's pretty, safe way to share your data. Fastest. Let's say you and your friend are sitting together. In between, you have an external hard disk. All the movies are in there. Or can you play a movie from the hard disk from two different laptops? You can't. The EBS volumes or even your hard disk, they are controlled by the operating system. Only one operating system will detect it. Alright, if it is detecting it, the other operating system will not even have a chance. So usually EBS volumes cannot be attached to multiple EC2 instances, just like your hard disk cannot be attached to multiple laptops. So every EBS volume only to one EC2 instance. Now if you want to transfer some data from here to here, you have to detach the EBS from this thing and then attach it to it. Just like you plug out from one laptop, plug in into another laptop. Very simple concept. That is EBS. All right, now let's get back to S3 a little bit. S3 has two other features: versioning, lifecycle. Also very two simple concepts. Versioning. What is a version? Any change is a new version usually. All right, just like Git. If it is Git, we are talking about code. So you write in a code, then you scratched it, and then you rewritten that code. So that's version 1, version 2, version 3, the same thing. If it is S3, you're essentially talking about objects. Let's take two objects. PDF file. There is a PDF file, then there is a image. Let's say PDF1, image1. Let's say this is PDF1.pdf, image1.jpg. That's the image format. Let's say you have image1 because it's S3 and it is object storage. If you want to edit image1, how do you do that? Can you double click on G drive and start editing an image? You can't because it's object storage. So what you do, you download the image, you use some Photoshop or some GIMP on your laptop to edit it, then you store it, then you upload it. Let's say you've done it and you uploaded it with the same name again. What G drive will do? It will replace. S3 can keep track of both. That's your version. So at any point of time, you can keep updating new files with the same name. S3 can keep track of all of them. But it should be enabled, which means it is not enabled by default. The reason is, even though it can keep track, what exactly it is doing as a software, it is keeping a copy of this, it is keeping a copy of this, everything it's keeping a copy. Now obviously you have to enable it. The reason is it's going to consume 2 times your storage. Other one, it's also illegal. Unless you tell it to keep a copy, it should not keep a copy, isn't it? So those are the two things, which means versioning has to be explicitly enabled. Now these S3 is usually called buckets. So you create a bucket, you put objects into it. That's what AWS calls them. It's like a folder. So you come across words like S3 bucket. Create an S3 bucket. A bucket is a storage. This usually is a URL. You will see HTTP colon AWS blah 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 like that. Each bucket has a unique name. Another thing about buckets is buckets have unique names across AWS. Means if anybody else has created a bucket with name ABC, you cannot create it. It's not per account. It's across AWS. The reason is they should be accessible anywhere. That's their point. So bucket names are unique, and there's another theoretical thing. What they say is 9 nines durability. 1, 2, 3, 4, 5, 6, 7, 8, 9. I said 1, 2, 3, 4, 5, 6, 7, 8, 9. This is fifth one. 9 nines durability means what AWS says is if you upload an object to one of our buckets, it is 99.999999% guaranteed that it will not be lost. What's your guarantee on the laptop? If I put a file on your laptop, what's the guarantee you can give that it will not be lost? Let's say I trusted you, I put my file onto your laptop and I am paying you money. Are you sure this is safe? What's the guarantee you can give? Percentage of guarantee? 50%? Maybe it will be there, may not be there tomorrow, I don't know. But I'll take your money. 50% is what you can give. No, AWS gives 99.999999. Yes, it's very unlikely that your file will be lost. And the way they manage it is, we talked about data centers, availability zones, regions. They replicate it across availability zones. So if not at one place, your object is always there at some other place. And the reason why they are able to do it is, storage is pretty cheap now. What's your 1 TB external hard disk cost? 3,000. Now that is retail. If you're buying it bulk directly from Taiwan, it's going to be about 200 rupees. Very cheap. All right. So that's your S3. Now, when you have S3, there is another thing called life cycle. So versioning is, it can keep track of all the versions. You have to enable the version. All right. You can retrieve any version you want from a S3 bucket. You will see all these things when you're doing your workshop. Let's talk about life cycle. Now to give you a quick view of life cycle, there is an image that I put it onto the GitHub. All right, just open that image, this one, on the same page of our GitHub. Can I see that? All right. This is about the life cycle of an object which was put into an S3 bucket. Let's see what it is. I'll take a scenario. Let's say you uploaded a photo. All right. How frequently you would be accessing that photo? Let's say that you taken a selfie today. All right. You uploaded it to an S3 bucket. Now, what's the likelihood of retrieving that photo and using it for something? When would you do that? Tomorrow? Depends on how beautiful the photo is. Okay. Let's say you've taken a beautiful photo of yourself. When are you likely to get back to that photo and watch it? Right away. Well done. Okay. Then, very good. You want to admire it tomorrow? No? You don't want to admire yourself tomorrow? We use mirror for it. Day after tomorrow? Let's say you took a photo of your girlfriend or boyfriend. Would you admire it every day? No, you don't want to. Okay. So you're not likely to retrieve the photos and watch them every day. Not happening, right? So we don't really like to see the same things again and again. We would rather take a new photo, see the new photo. That's with photos. Let's look at an enterprise level. Instagram. Everybody is uploading everything to Instagram. How frequently these people are retrieving those photos? Let's take an example of when is the last time you looked at a photo that you uploaded 30 days before to Instagram? All of you have Instagram accounts? All of you have uploaded a photo? Right? When did you see it again? Never. Or the Facebook. Facebook, directly it goes. TikTok, super. Right? You don't even have to send anything. It automatically gets loaded to the server. All right? Which means when you are uploading these objects, very rare that you retrieve them and you use those photos or videos. For such a thing that is not used very frequently, we still have to pay the money for storage. If Instagram has to store, it has to store somewhere all the objects. All right, they are all photos are objects. So it is using some kind of object storage. It could be with AWS S3, or it could be with Google with another object storage. They have their own Azure, or they can set up their own servers, install a S3 kind of software. But they are essentially paying money to store those images and photos, objects. All right. But the usage of these things or the retrieval frequency is not always same. Only last 2 or 3 days images are retrieved more compared to a 1 week or 1 month or 1 year images. So what Instagram could do probably is, if something is not accessed frequently, why can't we move it into a low cost storage? Because heavily accessed things should be accessible fast. Means they are on some SSD kind of thing. Whereas not so frequently accessed thing can be put on a low storage, low cost, like a regular hard disk or probably a tape drive. Means there are lots of storage technologies. Some of them are costly, some of them are cheaper. SSD is the costliest one. Our flash drives are costliest ones. They allow really quick access. Means when CPU asks for data from a flash drive, it retrieves really quickly. Whereas a regular hard disk is mechanical in nature. There is a head which keeps rotating. Now because it's a mechanical thing, it is usually slow compared to a flash drive or SSD. So don't worry about the technology. So what we are essentially looking at is there are different types of technologies which will allow you to retrieve data fast, slow, slower, slowest. And depending on fast, slow, slower, slowest, you are charged. The fastest one is charged highest, the slowest one is charged lowest. Now, as a company, obviously they always want to reduce the cost, which means we can push some of our photos which are not accessed frequently to a storage which is cheaper. So you have, let's say this is fastest, this is slowest. We're talking about hard disks, all right? This is a little slower. So I can keep all my today's photos and yesterday's photos in the fastest storage because they are most likely to be accessed. Slower, probably last 1 week or 10 days, I'll put it here. Anything more than 30 days, I'll move it to slowest. Because very unlikely that anybody is going to access it. At least 99% of the people will not access it. So an object has to be moved from here to here depending on time. That is your life of your object, and it moves in a life cycle. This feature is provided by S3 and they give it different names. That's what you are seeing over there. So you have standard access, standard infrequent access. Infrequent means not too many times they are accessing. The slowest one is deep glacier. Above deep glacier is there is a glacier. You don't have to remember the exact sequence, you just understand the logic. There is something called standard access, there is something called deep glacier, means they throw it somewhere in a glacier probably, alright. Then you have in between intelligent tiering. Means AWS will decide where it wants to be put. It looks at the object, sees how frequently the object is being accessed. It will move across the tiers wherever it sees fit. This uses machine learning algorithms to decide what is the best way to do it. Now this is the default storage. And there are, in between, there are some other things. One of them is zone. You have one zone, I think. What is it? Multi-zone or one zone? Yeah, one zone, yes. We know AWS gives 9 nines, right? Let's say you don't want 999. These are stupid images. They are just storing them. All right. I don't want any 999, which means do not replicate it across zones. Only put it at one zone and give me the cost benefit. So if it is one zone, you have less cost. Usually you put images that you don't mind losing. Let's say you have a backup copy of backup copy. You don't mind losing a backup of backup, right? You still have a backup. How many backups you keep normally? Backup of backup of backup of backup? No, only one backup. Okay. A lot of people do that. Take a copy. I think there is a joke. Ticket, bus ticket. Somebody buys a bus ticket. What, the conductor asks him, what if you lose this bus ticket? I have a backup. I have another ticket. And that guy actually bought 2 tickets. That happens here. So you can have a single backup or backups of backups, or you can simply have one zone backup. All right. These are the 2 things related to S3. So that's all S3 is all about. So you have type, this is object kind of storage, this is versioning, it has life cycle. Now this life cycle can be automated, which means you can set up a mechanism. After 1 day, move it to Move it from intelligent tiering to standard infrequent access. After 10 days, move it to glacier. After 30 days, move it to deep glacier. You can set it up in a format and automatically AWS will keep moving those things. You don't have to manually move anything at all. All that you do is you keep uploading your photos, and your AWS S3 policy is set up. It keeps moving it across the tiers. All right, any questions here? This is all theory. You don't have to really remember anything. You just have to understand that there is such a feature available. If you really need to get in there and do it, there are documents. That's what everybody does it. Now let's move it EBS. EBS is basically a hard disk where operating system can be installed. And it allows editing of the files directly because it's operating system. It is attached to a EC2 instance usually. Only one at a time. Now the backups of EBS volumes can be taken. They are called snapshot. Snapshot of EBS volume. How do you take a backup of S3 bucket? You can do that, or you enable versioning. Versioning is a backup, isn't it? No? Versioning is not backup. Versioning is versioning. If you want a backup, you have to actually back it up into another S3 bucket. With AWS or any cloud, just try to remember the main features of any service. All right, you will not be able to remember everything. It's not possible. All right, but you should know what the service is actually used for, both for practical reasons and for interviews also. Nobody is going to ask you everything about Nobody is going to ask you all those tires. Even if somebody asks you, you will tell, I'll search in Google. Please don't ask me to remember this stuff. I know there is one thing at the beginning, standard access. At the very end, there is a glacier. That's all I know. Anything in between, I look at Google. All right? Do not remember unnecessary things. That's something that you have to be really careful. All right? That's EBS, snapshots. So this is a backup strategy used. This can be automated. You can say, take a snapshot of my EBS volume every 1 hour. That way, what is happening is your EC2 instance snapshot is available every 1 hour. So you're basically having a snapshot of your live environment. Your Apache server, whatever is happening, you're taking a snapshot of that one. Now, once you have taken a snapshot, this can be converted into volume and attach it to another EC2 instance. Let's say you want the current EC2 status, the snapshot of the current EBS volume of one EC2 in another EC2 instance. Let's take this thing. So you have one EC2 instance, all right? You have an EBS volume here. You got a requirement, like your developer says, I want the exact snapshot of this one in a other EC2 instance. So how you do it? You set up another EC2 instance. You take a snapshot of this one. You convert or create a volume out of it. Mount that volume here. So you got the exact same thing on second EC2 instance. This is a common requirement, a practical one. All right. Now compare it with the last one, EFS. elastic file system or file storage. Any questions in EBS? All right, let's look at the third one. Elastic file system. Now this is created after your EC2 EBS stuff. The problem with EBS is it can be attached to only one EC2 instance at any point of time. Let's say you have 10 EC2 instances. They have all Apache servers installed on it. They're creating a log file. What are the log files? Access.log, error.log. Right? Now, you want to monitor the log files using some system. All right? Let's say you have any monitoring system, for example, Elasticstack. ELK, let's call it. Don't confuse it. ELK is a monitoring tool which can gather all the logs and give you nice dashboards to show you where the problem is. So you have 10 EC2 instances. Some of them sometimes may have issues. They are not causing any problem right now, but there are symptoms. Like before you fall sick, you have symptoms. 2-3 days before, you start feeling the dizziness, you start feeling weak, cough, cold, all that stuff. That's when you should go to doctor, not after you are kind of done. So even for a enterprise level infrastructure, it's important to identify the symptoms so that you can prevent a problem, isn't it? You cannot wait till everything collapses, then start to fix it. That's not what everybody wants. Everybody wants, if there is a symptom, which means if there are errors in the log file, even unharmful errors, make sure we are catching those errors and we know that such a thing is happening. If we think that this is serious, take a preventive action. Now, in such a scenario, you want to capture all the logs from all the EC2 instances. But the logs are on your EBS volume. And to bring all these logs here, you have to actually go into each of these EC2 instances and bring the logs. That's one way of doing. Obviously, you can run a shell script that fetches everything here. All right? That's the oldest model. Or instead of storing the logs on EC2 instance itself, you can have a common storage outside and then directly store them on an external storage. So in this case, you don't have 10 locations. You have only one location where everything is directly coming in. In this case, you will say access hyphen ec2.1.log error hyphen ec2.1.log. Here, access hyphen ec2.2.log error ec2.2.log. You can customize the log name. So if you look here, you have all the files. So access hyphen ec2.1.log, ec2.2.log, ec2.3.log. The same way, error hyphen ec2.1.log, ec2.2.log. So all files are available at the same location. Now pulling these log files from a single location into your monitoring system is much easier, less error prone. So anytime when you need a common storage across EC2 instances, you have elastic file system. So elastic file system, in other words, is network storage. Anybody can access the storage if you are in the network. It is similar to NFS, network file storage or network file system. It's something like this. You can put a you know, array of hard disks in the middle of office, all right, over there. That is also connected to the network. It appears just like a hard disk on your laptop. You can mount that hard disk or that array onto your laptop and access it as if it is local. That technology was there long back. That is called NFS, Network File System. That box that we are putting in the middle, it has a chip, a simple motherboard. It also has an IP. The moment it has an IP, it can be accessed from other IPs or other systems or other servers. So that is your network file system technology that existed long back. The purpose of this one is have a common place where we can store all the data. Let's say a company has employee guidelines document. Now obviously all employees of the company need to have access to that employee document, all right? So they have a common server, that is NFS server it is called. They put all that files over there. Now people will not copy that file to their own laptops. You just connect to that one. It appears like a folder on your laptop. You double click it, you can see everything. But it is not on your laptop. It is on a different server, and that storage is usually called NFS. Similar to NFS, you have EFS. So you can create an EFS volume. Now this is important. You can mount it on multiple EC2 instances same time. This is not possible with EBS. So a EBS volume cannot be mounted on multiple EC2, or one EBS, one EC2 only. Whereas the EFS, because we are saying this is network, it is not associated or restricted to one EC2. You can put it anywhere on multiple EC2 instances. And usually it's used for storing all the common files, pulling everything together. That's what it is used for. All right. So that's your EFS comparison with EBS compared with S3. Those are the three types of storages available on AWS. Almost on all clouds, similar storages exist. Any questions here? The workshop today will have S3 related things, I think. Any questions? Shall we jump to Kubernetes? A quick one, 15 minutes Kubernetes. Let's start with the keywords. I'm going to write these things every day so that you remember it. Orchestration. That's what is Kubernetes used for. Then you have monoliths. Those are the big applications. Microservices. Those are broken down monoliths. All microservices are usually in containers. Now the good thing about Kubernetes is it's auto-healing, or it's called self-healing. There's another feature, auto-scaling. We'll talk about that thing. Now we are talking about architecture. I'll give you a quick overview of the architecture, and we keep repeating it every day. Consider two virtual machines. This is VM1, this is VM2. What's the purpose of the Kubernetes? Why we are trying to use Kubernetes? To manage a large number of containers. So here on VM2, let's say your container is running. You have a lot of such containers running on VM2. Wherever the containers are running, they are running inside a virtual machine, like EC2 instance. So you launch an EC2 instance and you start your containers in it, or the Kubernetes starts the containers in it. Now, wherever the containers are available, this is called workload. That's your next word. A workload is a group of containers. And the system, or the virtual machine where usually the workload runs, is called a worker node. You can have n number of worker nodes. Let's call it worker 3. This is worker 1, worker 2, worker 3, worker 4. Like that. You can have any number of worker nodes depending on how many containers you want to run. Each container, all these containers are running on virtual machines like your EC2 instances. All these things are controlled by Kubernetes components. Those components are usually on a different virtual machine. This virtual machine is called a master. So you have master node and lot of worker nodes. Master and worker. Now, if you want to really have your master also highly available, you can have multiple masters also. All right? We're talking about one master at this point. The master node is also an EC2 instance or a virtual machine. Kubernetes can be installed on a regular virtual machines or also on a cloud virtual machines. Just a virtual machine. Kubernetes has nothing to do with cloud. So here, the configuration of all these things is stored in a database. It's called etcd. etcd. It's pronounced as etcd, etc. d. That's what they call it. etcd. Accessing this etcd is done by using a process called API server. This is called Cube API. Everything is stored here in YAML format. So if you want to access etcd, you have to go through the API. And we say API is just a process, just like Apache server. So you want to talk to the database, talk to the Apache server first, or Kube API. Now talking to this HCD is done by various other components. Apart from these two, there's something called scheduler. A scheduler is the one that schedules the containers. Alright? Containers are wrapped in what are called pods. So Kubernetes always works with pods, not directly with containers. A pod should ideally have one container in it, but it can have more than one container also. That is called a pod. So Kubernetes is talking about containers. Containers are wrapped in pods. What is a pod? You know the pod? As there is a nice visual, I think you will be able to remember it. Pod. Not this pod. This is a pod. That's where the name comes from. Chikudgail. The things inside it are containers. The one that holds it is the pod. The same nomenclature here. Now you understand what is a pod? So containers are wrapped in pods. The recommended number of containers is always one, but you may want to have a couple of other containers also. That's also okay. So you have containers, pods. These are called nodes. You have a master node, a lot of worker nodes. On the worker nodes, you have pods. Pods are scheduled by scheduler. Scheduler gets the information from HCD through API. All right? Now the next component, controller manager. A controller manager manages lots of controllers. The one controller is, let's say, node controller. Another one could be a pod controller. There could be a lot of controllers. Each controller has a job. For example, what the node controller will likely to do, guess it? The node controller controls the nodes. To control the nodes, it has to know the information of the nodes, isn't it? So it keeps checking whether a node is up or not. What are the amount of resources used on the node? Is the CPU high on a node? Is the CPU low on a node? Just like, how would you manage a EC2 instance? The same things are done by the controller. There are a lot of such controllers, each controlling a different segment of this whole infrastructure. All those controllers are managed by the controller manager. So each one of you have a task. All of you are managed by another manager. Alright, that's what this is about. This is the manager of controllers. It manages the controllers, which means, let's say if the node control itself goes down, the manager will bring it back up. Alright? Remember, all these things are processes. Just like your Apache servers. A bunch of processes, each one having a different thing. Now, because there are so many processes, that's why Kubernetes is considered complex, because anything keeps going down. So what do we have now? Workload, containers, pods, nodes. In nodes, you have master and worker. This is wrong, right? Master and slave is the correct one, right? That's what the combination is always about. Master slave architecture, that's what you learn. This is master worker. They don't want to use the word slave, so that usually gets phased out. So you have master node and worker nodes. Worker nodes is where your workload is running. What is the workload? Your containers. Containers are wrapped in pods. Now you have 4 or 5 things. 1, 2, 3, 4. Yeah, controller. Now this whole thing is about containers, right? Now to run a container, we need some kind of technology. What's the technology you know of to run containers? Docker. Which means everywhere you should have Docker or some other container technology. We know Docker is just like Xerox. There are other container runtime interfaces. What are the other ones? Container D, CRI-O, Docker is the main one. They made containers popular. Now, any of these things are called container runtime interfaces. So, you have a CRI everywhere. You want to run containers, you should have CRI. Container runtime interface. So what do we have? We have a master, workers. Worker has workloads, which are containers wrapped around by pods, which are handled or created by the container runtime interface. Kubernetes current version is 1.20. Till now, or till 1.19, the default CRI is Docker. Means Kubernetes used to use Docker container runtime. From 20 onwards, they have dropped Docker. They've used container D. The reason is Docker was acquired by another company called Mirantis. Now you don't know what's going to happen with Docker in the next 2-3 years. They don't want to risk it. So they moved into an open source one, container D. That's the CRI now. You just have to remember all these names. So we're going to write down all these names again and again. So you have master, workers, pods, nodes, containers, CRI. There are the 2 important components. That's all. I'll stop there. You have what is called a kubelet and a kube proxy everywhere. So you have a kubelet here. This is also a process. Kube proxy. A kubelet, kube proxy, CRI are available everywhere. So CRI, kubelet, kubeproxy is available everywhere. Kubelet manages the pods. I think you have to write down somewhere. I don't have place here. Kubelet manages the pods. Means if a pod goes down, kubelet automatically brings it up. That automatic bringing up is self-healing. I'll give you some kind of material with all these sentences, but just write it down for now. The idea is you should be able to talk about the whole architecture of Kubernetes in 1 minute. In 1 minute. That's all it takes. Explaining it is later, but you should be able to talk about all the components in 1 minute. We'll try to reach that. So you have kubelet. Kubeproxy is basically the network part. These pods need to talk to each other across the nodes. The pods are usually shown in this hexagon. This is 1, 2, 3, 4, 5, 6. Yeah, those are usually hexagons. No, this is actually a pentagon. It should be. Yeah, that's how the pod is shown. The pentagon. 5 sides. That's how a pod is usually represented. Inside a pod, you have a container. A container is like your cube. All the pods across all the nodes can talk to each other. And who facilitates that talking? Kubeproxy. So kubelet is to restart the pods or relaunch the pods. Kubeproxy is to facilitate the communication. Any questions here? Anything you want me to repeat? I understand it's too much information, pretty dense. That's how it has to go. Let me repeat it one more time. Master, workers. Workers will have workloads. Workloads are containers wrapped around by pods. All these pods are handled by the master and the components in master. All information of the cluster is stored in HCD. Can be accessed only using the Kube API. The pods are scheduled by the scheduler. Other components are managed by controllers. All controllers are managed by controller manager. Every node should have the runtime. It will also have kubelet and kubeproxy. All right. Now the HCD is called key value type of database, which means something like this: name and code ID, place at the bar. So this is key. This is the value. So the whole HCD has this kind of storage. Compare this key value with your Oracle database. Oracle database is rows and columns. That's how they are different. HCD is key value databases, whereas regular databases are columns and rows. These are called relational databases. RDBMS, you must have studied it. These are NoSQL databases. They don't have any structure kind of. But HCD is specifically key value. So everything in HCD is like a key and a value. So we talked about some 5 or about 10 names. So workload, take it. Containers, pods, nodes. Then what do we have? 1 minute. So containers, pods, nodes. In nodes, you have master and worker. After nodes, you have HCD. Maintain the same order always. Cube API, scheduler, controller manager, container runtime interface, kubelet, kube proxy. How many we have here? Forget the workload part. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fantastic. A very good number. These are basics. Now Kubernetes is all about names. They want to use very fancy names. So instead of calling them basics, they call them primitives. So you are given 10 Kubernetes basics or 10 Kubernetes primitives. Make sure you maintain the same order. Containers, pods, nodes, HCD, kube API, scheduler, controller manager, CRI, kubelet, kube proxy. These 4 are available only on master. Alright. Now the last thing for the workshop. We can access the API using a command line tool called kube control. Kube CTL, that's a tool. So you execute commands using kubectl. Some people call it kubectl, whatever you want, you can call it. Kubectl or kubectl. This is a command line tool. You can install it on any Unix system or Windows system also. You can access the API. Why do you want to access the API? You want to retrieve data from the HCD. This is a command line, right? Just like command line, there is a browser-based app also. It's called a dashboard. Dashboard also has to access API only. Anybody who wants to talk to Kubernetes has to talk to API only. So you can use kubectl on command prompt to talk to Kubernetes or do anything with this cluster, or you can use dashboard to do anything. Why people use command line when there is a graphical user interface available? GUI is easy, right? Why kubectl or why kubectl? Why command line tools? Automation. Why anybody wants to use Linux? Automation. You write a script, it takes care of everything for you. So the command line tool is basically intended for automation. Also, the dashboard does not allow granular access, means you cannot really go inside into properties and do much, whereas kubectl will allow you to do. So all administrators have to use kubectl. The dashboard is more for an end user or somebody who is only doing basic stuff. So today's workshop, you are only just going to touch upon these two tools just to get a view of what is going to happen. You probably will not understand too much, but that's okay. All right, we are just trying to have a glance at it, how things are around, in and around. Now slowly we will go deep into each one. All right. So today's workshop will have tasks related to S3 and couple of tasks related to Kubernetes using your kubectl, or probably you will have also the dashboard installation task 2. We'll see that depending on whether you can finish or not. So the number of primitives we have 10. Make sure you remember that list in the exact same order. Any questions here? This is what is going to get you a job. This is going to get you a job, nothing else. Not Git, not Jenkins, no stupid stuff. This will get you a job. Now the good thing about this one is nobody knows it yet, even the interviewers. Which means if you know 20-30%, you can crack the interview. So make sure you pay attention here. You should be able to talk, that's all. Doing, it is not working completely. The software itself is not stable. So even if you can't do anything, nobody knows whether you can't do it or it's not working. So you are in a safe zone always. All right, we'll stop it here. I'll continue with your workshop if there are no questions. All right.